So the first thing we're going to talk about today is direct variations. We talked about the ratio of two variable quantities being constant. And it's when it is, if there's a proportional relationship that exists, that's called a direct variation. So right here, they're asking you to describe the slope, which is the change of y over the change of x. But if you have part of that line going through the origin, you could say that one of your y's is 0, 0, if it's going through the origin. So if we do y minus 0 and x minus 0, we end up with y over x. And as you remember, we just looked at proportionality in a previous lesson where if you divided the b by the a or the y by the x, and it was equal to the slope, it was proportional. So if we were to solve for y here and multiply both sides by x, these x's would cancel and y would equal mx. Later on, you're going to hear about an equation where it's y equals mx plus b. We'll talk about that in a minute. But here, the b is where it goes through y. And since it's going through y at 0, there is no b here. And so a direct variation equation is going to be y equals mx because it's going through 0 and there is no y-intercept. So direct variation, like we just talked about, is going through a graph that passes through the origin, and the relationship between the y and the x is direct. So here's an example of y equals 3x, where the slope is the change of y over change of x. We go up 3 and over 1. So 3 over 1 is your slope, m. So in this example, as you can see, it's going through the origin. And it says that the money Robin earns while babysitting varies directly with the time. So for every hour she works, it goes up the amount of money she makes proportionally. She doesn't make more per hour as she babysits more hours or less per hour. She makes the same amount of money per hour. So as we can see here, if we go up to, we find that it comes to a meeting point right here. And we have 15, because this point right here is 15 over 2. So if we look at that slope, which is the amount earned over the time, we get 15 over 2, or 7.5 over 1. So she earns $7.50 an hour for every hour she babysits. In the next example, you guys should try this one. 2 minutes after a skydiver opens his parachute, he descends 1,900 feet. After 5 minutes, he has descended 4,750 feet. So try doing this problem and finding out the ratio of the direct variation of the feet descended over the time. So, if the skydiver is falling in 2 minutes 1,900 feet, and actually he's going down, so it's going to be a negative 950 feet per minute. If he went down 4,750 feet in 5 minutes, it's negative 950 feet per minute, because it's a proportional relationship. It's a set amount of velocity as he free falls from the airplane. Okay, so if we're going to move on to the next lesson, and here we have a real-world example where an interception in football is when a defensive player catches a pass made by an offensive player. In a non-proportional linear relationship, the graph passes through a point 0b, or the y-intercept. The y-intercept, this is really important not to forget, is a point where it's going through the x-axis at 0, but it's not going through the origin, the y point at 0. So once again, we have y2 minus y1 over x2 minus x1 is equal to the slope. And it's going through a point B on the y-axis, so we have y minus b, and x minus 0 is x. Now we're going to want to solve for x. And that means that we're going to multiply both sides by x. Oh, I did that on the wrong side. Hold on. By x here. They cancel here. And so we've got y minus b is equal to m times x, the slope times x. And then we want to add b to both sides to get y by itself. So y is equal to mx plus b. This is going to be the most common equation that you will use when solving linear equations. Y equals mx plus b. It's called the slope-intercept because m is your slope, rise over run, and b is your y-intercept. And that's where the graph goes through the y-axis. This is your y-intercept. I like to remember that m is the mountain for slope, and b, the y-intercept, is where you begin your graph. You're going to see when we go to graph these equations, you're going to begin your graph at the y-intercept, which is b. Okay? All right, so the slope-intercept form of a line. Like I said, this is probably the most common equation you're going to use when we're working with linear equations, which is a huge portion of algebra. Here we have a y equals mx plus b equation. M is 2/3. It's not 2/3 x, it's just 2/3, and that's your slope. And b is your y-intercept. So if you were to graph this equation, like I told you before, B is where you begin on the y-intercept. It's kind of like a missile that's intercepting an object, right? It's going to intercept your y-axis at -4. Okay? So that's your B right here, -4. Then you're going to use your slope of 2/3 to count your mountain. Remember I said m is equal to 2/3. That means you're going to go up 2, 1, 2, and over 3, 1, 2, 3. And that's how you graph the line. Up 2 over 3. All right, so the directions on this independent practice is to just give the slope and y-intercept, but we're going to graph them also. So your slope is your m, which is 3. Your y-intercept is 4. So if we're going to graph it, we will begin our graph at B. Begin at B, right, Ivan? You're a star, you're on the recording.
Wait, I'm not Ivan.
And then the mountain, rise over run. I'm going to go, it's going to be 3 over 1, right? So I'm going to go up 3 and over 1.
Wait. Oh.
Right? Up 3 and over 1. On this one, my mountain is negative 3/7. And my beginning, or my y-intercept, is negative 1/7. So for me, when I do these, I like to make this 1. And 1/7, negative 1/7 is about right here, right? Because if you broke that up into sevenths, it's right after 0, isn't it?
Yeah.
So I'm going to go down 3 and over 7. So I have to do this. Here's 1 and 1/7, 2 and 1/7. To go down 3, I have to go 1, 2, 3, and over 7. 1, 2, 3, 4, 5, 6, 7. So here's my graph. Negative 1/7 is where I begin, right here. And then I'm going to go down 3 and over 7. So 1, 2, 3, and then over 7.
Hey, Miss Cindy.
So on this last one, my slope is 3, not 3x. Oh, no, it's not. I have to get the y by itself so that it's in y equals mx plus b form. See how the y is all by itself? So I've got to subtract the 3x from both sides. And I get y equals, the negative 4 and the 3x can't be combined because the 4 doesn't have an x. So I'm going to put it in y equals mx plus b form. Don't forget your negative on your 4. And now I can graph. My y-intercept, which is b, is negative 4. My slope is negative 3 over 1, which means I'm going to go down 3 and over 1. I could go positive 3, 1, 2, 3, and negative 1. And as you can see, it's on the same line.